Hello and welcome to Learn Statistics class. In this class we are going to study the statistical concept in simple and more easy way. The topic of today's lecture is continuous uniform distribution. So let us start with the continuous uniform distribution. In this topic we are going to study the definition of continuous uniform distribution and the distribution function of continuous uniform distribution. So we shall start with the first point, definition of continuous uniform distribution. The simplest continuous probability distribution is the uniform distribution. A continuous random variable x is said to follow uniform distribution over the interval a to b if its p.d.f is given by, here p.d.f is probability density function, which is abbreviated as p.d.f and denoted by small fx, and it is given by fx equal to 1 upon b minus a for the range a less than equal to x less than equal to b, and it is 0 otherwise. Means the p.d.f of continuous uniform distribution is 0 other than the range a to b. It is denoted as x follow u for uniform a comma b. This is the notation of uniform distribution over the interval a to b. The continuous uniform distribution is also known as a rectangular distribution. It is called so since if we plot the p.d.f on a graph paper, then it looks like a rectangle. Let us draw the p.d.f of continuous uniform distribution. Take the value of x on x-axis. Since we have the values of x in between interval a and b, all the values lies between this interval a and b, and the value of p.d.f along the y-axis means fx equal to 1 by b minus a along the y-axis. If we plot the points, then we get for all values between a to b, the value of p.d.f is same, which is 1 by b minus a. Means from a to b we get all the points at the point 1 upon b minus a. If all these, since there are infinite number of points between a and b, all these points are between a and b and they form a straight line between the point a and b. And if we draw a perpendicular on x-axis, after drawing perpendicular on x-axis, it looks like a rectangle. This is the value of x along x-axis and p.d.f along y-axis. After plotting all the points of x at p.d.f 1 by b minus a, the graph looks like a rectangle. Hence, the continuous uniform distribution is also known as a rectangular distribution. Now, let us move to the second point of the topic continuous uniform distribution, and that is the distribution function. The distribution function is also known as cumulative distribution function, and it is abbreviated by c.d.f. So, let us start with the cumulative distribution function c.d.f, which is also known as a distribution function. If x follow uniform AB, then the distribution function or c.d.f of a continuous random variable x is defined as, the c.d.f is denoted by fx, and which is nothing but probability x less than equal to x. Since x is continuous, we calculate this probability with the help of integration minus infinity to x ft dt. Here ft is the p.d.f of continuous uniform distribution. Since continuous uniform distribution varies from a to b, the lower limit is a, integration is from a to x 1 upon b minus a dt. As this 1 upon b minus a constant, take outside the integration sign, integration a to x dt. We know that the integration of dt is t. So, it is t limit is a to x. Therefore, the c.d.f of continuous uniform distribution is 1 upon b minus a, put upper limit minus lower limit. Hence, c.d.f or distribution function is f of x equal to x minus a divided by b minus a. This is the value of c.d.f of continuous uniform distribution. We shall write this c.d.f as fx equal to, this c.d.f is 0 for x less than a, and it is x minus a upon b minus a for the range a to b, and it is 1 for x greater than b. This is the distribution function of continuous uniform distribution. In the definition of continuous uniform distribution, we have defined a continuous random variable x which follows a continuous uniform distribution over the interval a to b, where a and b and B are constants. Constants such that A is less than B, and they are known as parameters. Parameters of continuous uniform distribution. In this way, in this lecture, we have learned the definition of continuous uniform distribution and its distribution function or cumulative distribution function. In the next lecture, we will meet with the next term of continuous uniform distribution. If students want to learn this more statistical concepts, then click on the I button at the top right corner of the screen, and link of that lectures are also given in the description box. If students like this video, then click on the like button and share with your friends to study the statistical concepts in simple and more easy way. For more statistical concepts, we shall meet in the next lecture soon. Till then, we will stop here. Thank you.